Greetings and welcome. This is Mr. Waddy, and I'm going over the homework from Geometry 7.1, where we were talking about the angles within a polygon. And we had a couple of equations for both the sum of the measures of the interior angles of a polygon and the measure of exterior angles of a polygon, where there is one exterior angle at each vertex. So the first equation that we had was S, the sum of those angles of the interior angles is equal to n minus 2, where n is the number of sides the polygon has. And it must be a convex polygon, so it can't have any dents in it, or concave polygon. And I multiply that by 180. We derived this formula, or we kind of like understood and experienced this formula in a couple different ways yesterday, so you can check out the lesson video if you need to. And so here it says, find the sum of the measures of the interior angles of the indicated convex polygon. So a nonagon is actually n is going to equal 9. That's what a nonagon is, a 9-sided convex polygon in this case. So if I want to find the sum of its interior angles, I would simply plug 9 in for n, subtract 2, multiply by 180. So that's going to be 7 multiplied by 180, which is 1260. So the sum of the interior angles of a nonagon will be 1,260 degrees. So that's just a straight use of the formula, but as algebraticians and not just geometricians, we also like to use formulas backwards. So it says, okay, if the sum of the measures of the interior angles is given, classify the polygon by the number of sides. So in this case, I know I'm looking for n, right? I don't know the number of sides, and I happen to know the sum is 2520. So I'm going to plug that into the same formula. So 2520 sum this time, times n minus 2 times 180. And I'm going to now solve this for n. Now, in this case, I could distribute and then solve, but I realize it's actually beneficial to divide both sides by 180 right now, as it is. So I will do that. So divide both sides by 180. So 180. And so I'll have 2520 divided by 180. And I get 14. That is not the number of sides yet. So 14 is equal to n minus 2. And then to solve for n, I'll add 2 to both sides. And I get n is equal to 16. So that means that this is a 16-sided polygon that would have sum of its interior angles 2520. All right, next example. Let's see. It says find the value of x. Now we had a corollary to the sum of the interior angles, where we said that any quadrilateral that is convex will have the sum of its angles be 160. So to do this for question 13, I would just simply plug in x plus 29 plus 88 plus 154. I know that the sum of all of its interior angles is going to be 360 degrees. And so I just add them all up. If there were some other expressions here, more complicated than that, or different versions, x or 3x or x plus 1, I would just plug those in as is. See, let me combine the like terms on the left-hand side here. And I get x plus 271 is equal to 300. Subtract 271 from both sides. Let's see, and I get x equals, minus second answer, 89 degrees. So I'm able to find measure of one of those angles like so, right there. So just kind of a matter of using that fact. If I didn't know that corollary, I could have also counted the number of sides, realized that n is equal to 4, and used the previously given formula to find out that the sum of a 4-sided convex degree. So if I was shortchanged in not knowing that, I could just that and then set it equal. All right, similar idea. Oop, here we go. Question 19. All right, so it says find the measure of angles x and y. So notice these two angles are congruent. So I'll just call those both x degrees. Maybe I'll have to pick a better name. I'll call them z. Both of those angles are z degrees. This is a right angle by definition of right angles. That's a 90-degree angle. There are 1, 2, or 5 sides to polygon. And so I'm going to end up setting up an equation where I'll have z plus z, or I guess I could skip and just write 2z plus 90 plus 102 plus 164 is going to equal, and whatever the sum of a 5-sided polygon is. At some point, you just start to remember these. So for a 5-sided, the sum is going to be 500 degrees, or right, 5 minus 2 is 3, and multiplied by 180 is 500 degrees. So I'm going to set the sum of all of these interior angles to 503 degrees, and now solve. So I'll have 2z plus, I'll add up those like terms, those constants, 90 plus 1 plus 164, 356 equals 540. Subtract 356 from both sides. And I'd have 2z equal 540 minus second answer on my calculator, 184. Then divide both sides by 2. And what do I get? Z is equal to 92. And since they asked me for the measures of those angles, I could with more clarity say that the measure of angle x is 92 degrees, and conveniently the measure of angle y also 92 degrees. So there would be my answers. Did I give ourselves one more problem? Did. Hooray, good. That's right. Yeah, I hope we have the exterior angles here. So if I take a polygon and extend its edges out, creating rays, these angles are called the exterior angles. They are, if I pick just one of them from each vertex, because technically, imagine another 85-degree angle right here that's a vertical angle to it. But just one of those from each vertex. If I add up all of those, no matter the number of sides, I will have 360 degrees when I add those all up. So that's essentially all I have to do here is 2x plus 3x plus 71 plus 85 plus 44. And I don't have to do math for different numbers of sides. It's just any polygon. It's going to add up to combining like terms, 2x plus 3x, 5x plus 71 plus 85 plus 44. Get 100 equals 360. Subtract 100 from both sides. And then really, the way they try to make these problems more interesting is throwing more algebra into the mix. But the geometry isn't that bad. So 60, divide both sides by 5. Let's see, 10 would go into 160 16 times, and 5 should fit twice as much. So I'm assuming my property that x is going to be 2. And just make sure I'm answering the question. They wanted the value of x, not the measure of those angles. I'm fine with saying x equals 32. All right, well, thanks for watching, Internet friends. Great day.